Good day, everyone. Here is the outline of our discussion for today. First, I'm going to discuss about the first and higher order notations of derivative. This will be followed by an example and also followed by a practice problem that you are going to solve if you want to. Okay, first order and higher order derivative notations. Now, in mathematics, for me, it's very important to know first the notations or the mathematical symbols that we are going to use for a certain topic, because this is one factor why students get confused or why students are afraid of mathematics, because in the first place they do not know what we are talking about or what these symbols all about. So we start with these notations, but we have to take note that the following are equivalent notation for derivative of the given function. We start with the first one, the f prime of x. Now f prime of x is what we call the function notation of the first derivative. So this is used if the given function is f. So for example, if f of x is equal to 2x, then the derivative of that is denoted by f prime of x is equal to 2. The second one is y prime. Now y prime is the notation for the first order derivative, and this is used if the given function notation is y. So for example, if the given function is y is equal to 2x, then the first derivative is denoted by y prime, which is equal to 2. The third one is dy dx. This is what we call differential notation, and this is another notation for derivative which is not the quotient of two separate entities, dy and dx. So this is notation. This doesn't mean that dy is divided by dx, since this is just a notation. Okay, the fourth one is what we call the operator notation with respect to x. Then this serves as a machine that generates on the function f to produce its derivative. Okay, this d sub x here, this serves as a function or an instruction that you are going to find the derivative of f of x with respect to x. Okay, now we have to take note that the notations above, the first four notations, are the notations for the first order derivative. For the higher order notations, we have this d squared y over dx squared, which is equal to f double prime of x, which is also equal to y double prime. Now these are the notations for the second order derivative. Now if the given function is f, and if you are asked to find the second order derivative, then you can use f double prime of x. If the given function is y, then you are asked to find the second order derivative, then you can use y double prime or d squared y over dx squared. Okay, now generally speaking, we have this notation d squared d raised to ny over dx raised to n. This is the notation for the nth derivative of y with respect to x. So for example, if you are asked to find the fifth order derivative of y, for example, then you can have d raised to 5y over dx raised to 5. That is the fifth order derivative. Okay? Generally speaking, again, these are other notations for the nth derivative of y with respect to x. So we have examples on higher order derivative. The problem is find all the derivatives of the function f defined by this. Okay, we have f of x is equal to 8x raised to 4 plus 5x raised to 3 minus x raised to 2 plus 7. Okay, now we are asked to find all the derivatives of the given function. So first, we have to solve the first order derivative or the first derivative, which is, since the given function is f, so we can have the notation f prime of x. Okay, you know this already because we already discussed some of the theorems of finding the derivative. So you just simply multiply the by power rule, multiply this exponent 4 to 8, so this becomes 32. X raised to 4 minus 1 x cubed plus 3 times 5 is 15. X raised to 3 minus 1 is 2. Then minus 2x, and the derivative of 7 is 0. So, in order to get the second order derivative, you have to get the derivative of the first order. Okay, the derivative of this. So, 32 times 3 is 96, x raised to 2, plus 2 times 15 is 30x minus 2. For the third order derivative, you just have to get the derivative of the second order derivative. Okay, then this is 192x plus 30. Then the fourth order is, so here we use already the n, which is equal to 4. So f raised to 4 of x is equal to 192. Then the fifth order is equal to 0, and also the sixth order, and so on. So these are the derivatives of the function f. And for n greater than or equal to 5, the derivative is 0. Okay, what are the derivatives? These are the derivatives: the first order, the second order, the third order, the fourth order, the fifth, and the sixth, and so on, becomes 0. Okay, now for a practice problem, I have this function which is equal to 1 over x cubed. Then you are asked to find the first and second order derivative of the function f, that is d over dx of f of x. So this is also a function notation. This is like an operator notation, that you have to get the first order derivative of f of x. Then you have to get also the second order derivative using this notation of f of x. Okay, now if you want to show your solution, you can just comment, or you can just put your answer in the comment section. Thank you so much, and hope you like this video. And just keep sharing what you learned from this video. Thank you, and God bless.